So in the second normal form, what we have learned is we have learned like if any functional dependency will have the partial functional dependency in the relation or in the table. So that particular relation will not be in a second normal form. It means that there should not be any partial functional dependency. So the rule of the second normal form is, first of all, it should be in a first normal form. It should be in a first normal form, and the second criteria is there should not be any partial functional dependency, right? There should not be any partial functional dependency. What is the meaning of partial functional dependency? It means that part of the key, if it is determining some non-key, then it is a partial functional dependency. So that thing we do not want in our relation, that any part of the key is determining some non-key. If we are getting it, it means that it is not in the second normal form. Okay. So let's begin the question. Let's start with question number 1. We have a relation and that relation has some attribute like A, B, C, D. 4 attributes are there. And we have the functional dependency. This functional dependency what we have is first is AB determines CD and the second one is B determines C. Okay. So this is my partial dependency given. The question is normalize up to second normal form. Okay, normalize up to second normal form. Let's go for the solution. Now, while making the solution for any normalization process, first step will be to find out a candidate key. So first will be find the candidate key. Okay, find the candidate key. So for finding the candidate key, what we have to do is we have to find out the closure. We have the functional dependency only 2. This is one functional dependency. This is another functional dependency. So we'll first go for the first functional dependencies determinant part, means AB. So we'll find out AB closure. What is AB closure? AB closure will be AB. AB is determining something. Yes, they are determining C and D. So we are getting R. It means that AB is the candidate key. Do we have B closure? B closure will be B and C. That's all. It is not equal to R. It means B is not the candidate key. So we got the candidate key. So the candidate key will be AB, right? Now, if we got candidate key, the second step would be check for second normal form. Okay. So what the second normal form says that it says that there should not be any partial functional dependency. So for that, what we do is we'll check the first functional dependency. What is that first functional dependency? AB determines CD. Is this satisfied the second normal form? AB determines CD, because AB is the key itself. It is not the part of the key. So if it is not the part of the key, means it satisfies the second normal form. Let's go for the second functional dependency, which is B determines C. Is it satisfy the functional dependency? Now B is the part of the key because AB is the key, right? So B is the part of the key. So we say it cannot satisfy the second normal form. So what we have to do? We have to split, right? We have to split the relation. So the relation is A, B, C, D. This will be divided into two parts. In one relation, we should have this functional dependency, which is B and C. And so it will be, let's say, R2. And in R1, we should have A, B determine C. C is already there, so it will be D. So in one relation, we have A, B, and D. Another relation, we have B and C. So for this, the functional dependency would be AB determine D. And for this, the functional dependency would be B determines C. Now, as an individual table, R1 and R2, R1, there will be no partial functional dependency. For R2 also, there is no partial functional dependency. Because for R2, B is the key, right? If we'll find out B closure, it will be BC, BC equal to R2, right? And for the R2, B is the key. And for the R1, AB is the key. So here, this is also in second normal form, and this is also in second normal form.
Sir? Sir?
Yes.
Sir, why ABD in the R1?
Why ABD? Because we should possess the candidate key. So the candidate key is AB. So we should have in any of the table, we should have AB. Now, as the functional dependency says that AB determine C and D, because C is the part of this particular table. So the rest one is D. Okay. So with AB, I have put it D. And BC is creating the problem. So BC we are putting in one table. So BC in one table. Why? Because it is not satisfying the second NF. So we'll put the BC in one table, and we'll try to put, because in this particular functional dependency, all the attributes are there. We cannot put all the attributes because already C is the part of R2. So C will be removed from here, and the functional dependency again could be used, as well as we have to put the candidate key in any of the table. Okay. So that's why the R1 will be A, B, D, and R2 will be B and C. Any other doubt?
No, sir.
Okay, let's do some more.
Sir, so can you tell that if you have a function dependency with addition to this, if you have A determines D, then sir?
Okay. let's say we have a relation A, B, C, D. The functional dependency AB determine C, D, B determines C, and what you are saying?
Determines D, sir.
A determines D. Now, in this case, if candidate key, what is the candidate key? AB?
AB, sir.
AB is the candidate key. So for first functional dependency, which is AB determines CD, it satisfies second enough, right? It satisfies.
Yes, sir.
For the functional dependency B determines C, it doesn't satisfy the second normal form because it is a part of the key. For the third functional dependency, which is A determine D, again, it does not satisfy the functional dependency because this one is the part of the key.
Yes, sir.
So to solve that, the R, which is A, B, C, and D, will be divided into some relation. Okay, so first of all, because these two are creating the problem, we'll just put into separate table. Let's say B and C will be in one table, and A and D will be in another table. Okay.
Yes, sir.
So, and because of this candidate key, we have to have another relation in which we have AB together. Okay, so this is showing the candidate key, and this is B determines C, this is A determines D, right? So now in R2, B determines C means B closure, B is the candidate key for R2. For R3, A is the candidate key. Getting it? And for R1, see, for R1, because it is the candidate key itself, so we have to put that in one table. Okay, that is a requirement.
Yes, sir. Got it.
Okay. So let's do some more questions so that we can understand it. There is no no rocket science here. We just understand by doing some more questions. Okay, let's go for another question. We have a relation where we have P, Q, R, S, and T. So we have 5 attributes here. The functional dependency, what we have is PQ determine R, as determine T. Okay. Or we have to solve up to second normal form. This is my question. So solution, the first will be the process of find candidate key. All of you do the questions along with me. Okay. So first of all, we have to find the candidate key. So we'll find the candidate key using the functional dependency. So the first functional dependency is PQ determine R. So we'll find out PQ closure first. So we'll get PQ and R. That's all, I think. Second one is S closure. So we'll get S and T. I think that's all, which is not equal to R. It is also not equal to R. So what we do is we add some more attributes. So let's say if we'll add P, Q, and S together, do we get? So for PQ, just write it down, PQ and S. PQ are determining R and S is determining T. So P, Q, R, S, and T we got, which is equal to R. So now we can say that P, Q, S are the candidate key. Okay, PQS is a candidate. Now, let's go for the second step. It is check for second normal form. We'll check the second normal form with first functional dependency, which is PQ determine R. Here, PQ are the part of the key, right? So it is not satisfy second normal form. Second one is as functional dependency is as determine T. So here it is also not satisfy second normal form. Why? Because S, which is the determined part, is a part of the key. What is the key? Key is PQ and S. Okay. Now what? Now we have to split the R. R is P, Q, R, S, and T will be divided into some. So this is creating problem. This is creating problem. So we'll make a separation of it. So let's say I will make R1 as P, Q, and R. R2 as S and T. And R3 will put this particular candidate key together, which is P, Q, and S. Any doubt here? So here the functional dependency will be PQ determine R. Here the functional dependency will be as determine T. And here it is a candidate key. We are putting together in one table.